In Part 4, we moved away from the aliens and introduced the Googol family. Now, instead of counting the number of zeros in any given power of 10, we are instead counting the height of a power stack. In making the switch from the aliens to the Googols, we lost the precision of Jonathan Bauer's system, for in the aliens, every integer between 1 and 1 multillion has a unique name. The Googols, of course, do not have this property, but in what we lost in precision, we gained in the ability to go extremely big, extremely quick. Right here at a googolcentiplex, we are already so much larger than 1 multillion, it is actually quite legitimately impossible to convey. And remember, each time we add a 10 to the stack, we are not increasing the size of our number by a mere factor of 10. This number right here, 1 googolmegiplex, has a googolcentiplex zeros. And a googolcentiplex, of course, has a googolmilliplex zeros, which itself has a googolocteplex zeros. If the rate at which the Tier 4 aliens grew was beyond all human comprehension, well then this is beyond the comprehension of the Tier 4 aliens. Of course, you've probably been able to figure out how the naming convention continues on by now. This number right here is a googolcentiplex. The number 10 is sandwiched 100 times between the 10 at the bottom of the tower and the 100 at the top of the tower. Likewise, a Googolmilliplex has 1,000 tens between the 10 at the bottom of the tower and the 100 at the top of the tower. After a Googolmilliplex, you of course have a googolduplex, a googolmegiplex, all the way up until you reach a Googolmicriplex, a number with 1 million tens between the 10 at the bottom of the tower and the 100 at the top of the tower. Of course, after a Googolmicriplex, you have a googolnanoplex, corresponding to 1 billion tens, a googolplex, which has 1 trillion tens, and, well, hopefully you're familiar with how the prefixes go. And just remember, the jump between each one of these numbers corresponds to a 1,000 times increase in the number of tens in the power stack. If you were to write out a Googolmilliplex as a stack of tens, all within a meter of space, then in order to write a Googolmicriplex as an exponent stack, and in the same size handwriting, you would need a kilometer of space. To write out a googolkilliplex in the same size handwriting and as an exponent stack, you would need to write to the moon and back again 2 times over. To write out a googolkilliplex in the same size handwriting and as a power stack, well, the diameter of the observable universe is only about 88% of the length that you would need. This is not the space that you would need to write out the entire number in decimal notation. This isn't even the space you would need to write out the number of digits in the number. This is how much space you need to write it as an exponent stack. Every single millimeter, there is another number 10 in the exponent stack, and the observable universe still does not offer enough length to write out a googolcentiplex. These numbers are large, and they are certainly useless, but we can still give them fun, unique names. Take this number right here, for example. Imagine there are 8,456,902,189,112 tens between the 10 at the bottom of the stack and the 100 at the top of the stack. This number right here would be called 1 googoloctopike sexcundesi quadracentenani do nonagentamicri non-deci octocentimilli do decicentiplex. Try saying that 5 times fast. But of course, we don't have to stop at a googolkilliplex. We can talk about a googolmessiplex, a googolcentiplex, a googoltriacontiplex. These prefixes should all look familiar from one of the previous parts. The only difference being that here, the jump between a googolhexacontiplex and a googolheptacontiplex, for example, is so much greater than the jump between hexacontillion and heptacontillion. A googolheptacontiplex has a non-nillion times as many tens in its power stack as does a googolhexacontiplex. And a googoloctacontiplex has a non-nillion times more tens than a heptacontiplex in its power stack. It doesn't have a non-nillion times as many digits. It has a power stack that is a non-nillion times longer. Already, a non-nillion is a mind-bogglingly huge number. But when you start to talk about an exponent stack being a non-nillion times longer than another, that doesn't even make sense. I feel foolish even using a space backdrop in this video. By the end of part 1, we were already well past the scale of the observable universe. And by the end of part 2, we were grasping at straws, trying to use combinatorics to describe the size of these numbers. But here, in part 5, there is simply no possible way. It is already beyond all human ability to visualize just how many tens are in the stack for a googolduplex, much less visualize what the actual size of that number means. Just the mere height of the power stack is beyond our ability to grasp. What hope do you possibly have of imagining the magnitude of the number itself? Eventually, you reach a googolkilliplex. A googolkilliplex, represented as a power stack, has 10 to the 3,003 tens between the base and the exponent at the top. These numbers, the googols, they grow so fast. And I wish that I could convey to you just how large these numbers are. But I can't. And not because I am weak, but because it is impossible. No mortal can. No mortal could ever hope to convey to another just how big these numbers have become. A Googolmegiplex, a number with a micrillion tens between the base of the tower and its peak. A googolgigiplex, a number with a nanillion tens between the base of the tower and its peak. A googolteriplex, a number a pikillion tens tall. And then a number that is a femtillion tens tall is a googolplex. And remember, each of the googols between a googolciplex and a googolcentiplex, and each of the googols between a googolcentiplex and a googolmilliplex have their own unique identifier. It's just a matter of, are you willing to sit here for the next eons to pronounce it? Just remember that the googolkilliplex, although it is impossible to describe how much larger it is than a googolmilliplex, it is likewise impossible to describe how much smaller it is than a googolhendiplex. How far does it go, you might ask? Well, to answer that question, all you have to do is look at the previous parts of the series, and you will realize we can talk about a googolmiciplex, a googolcentiplex, a googoltrolleyplex, a googolmegiplex, and hundreds more in between. We can work ourselves all the way up to a Google multiplex. This is a number so large that I shan't even attempt to describe it. If expressing the sheer magnitude of the other numbers in this video is futile, then how much more so is this? I like to go through these videos slowly. Going through these numbers at a lesser pace gives one time to digest their enormity. Not to comprehend their size, for that has not been possible for a long time in this series. But enough time to chew on the fact that no matter what, you will never be able to digest their size. Going through these numbers slowly, building our way up, step by step, gives one time to grasp the hopelessness of ever trying to understand the size of these numbers. But with the Google multiplex, it doesn't matter how long I spend on it, how many times I emphasize just how impossibly huge this number is. You will never grasp the hopelessness of understanding this number. You may recognize that, yes, it is futile to try and wrap your brain around a Google multiplex, but you will never realize just how futile it is. You may recognize that it is impossible, but you will never know just how impossible it has become. Now, before we go, there is just one thing that I would like to mention. There may be some of you out there who are somewhat familiar with Tetration, who are wondering why we didn't just write a Googolmicriplex like this. After all, it saves space, it's much easier on the eyes to look at. The only problem is that these are not equal. What we have been doing in this video is not, in fact, tetration. It may be growing at a somewhat tetrated rate, yes, but it is not, in fact, tetration. 10 to the 10 to the 100, aka a googolplex, is not equivalent to 10 tetrated to 2, all raised to the power of 100. One of these numbers has a googol zeros, and the other only has 1,000 zeros. So while it may be tempting to write a Googolmicriplex as 10 tetrated to 1,000,000, all to the power of 100, you unfortunately cannot condense it down into such a nice small space. If you still want tetration, though, that is, repeated exponentiation, well then luckily for you, the Googol family has a relative. A relative powerful enough to make anything we discussed in this video feel like a wisp in the wind. You can thank Jonathan Bowers for this one too. These are the giggles. Coming up in part sit.